Something is moving beneath the ice of a moon 390 million miles from where you are sitting right now, and NASA does not yet know exactly what it is. Not a theory, not a simulation, a real physical unknown, sitting under a crust of frozen water thicker than entire mountain ranges, on a small moon orbiting the largest planet in our solar system. And here's the part almost nobody is talking about. We are already flying a spacecraft toward it. It launched years ago. It is moving through deep space at this very moment. And when it arrives, humanity may get the closest thing it has ever had to a direct answer to the question that has haunted science for a century. Are we alone? This is not science fiction. This is an active NASA mission already underway, already producing data, already forcing scientists to rewrite what they thought they understood about Jupiter's largest moons. And the closer you look at what has been discovered in just the last 2 years, the more it becomes clear that something extraordinary is unfolding in the outer solar system, quietly, methodically, and largely out of public view. To understand why this moment matters, you have to go back further than most people realize. Back to a winter night in January of 1610, when a man named Galileo Galilei pointed a handmade telescope at Jupiter and saw 4 small points of light that refused to behave like stars. They did not stay fixed against the sky. They moved. Night after night, he watched them shift position, and within days he understood what he was witnessing. 4 moons, orbiting another planet, proof that Earth was not the center of everything. It shattered the accepted model of the universe. It nearly got him imprisoned. And those 4 moons, Io, Europa, Ganymede, and Callisto, became known as the Galilean moons, named after the man who dared to look too closely. For over 400 years, they sat at the edge of human curiosity, distant, icy, mysterious. But here is where it gets worse for anyone who assumed we had already learned everything useful about them. In March of 2026, scientists confirmed that Jupiter now has 101 officially recognized moons. And that number still does not capture the true complexity of what is orbiting that planet, because there are thousands of smaller objects, rings and debris fields, tangled in its gravitational grip. Jupiter is not just a planet, it is practically its own miniature solar system. And at the heart of that system are 4 worlds that may be hiding more than anyone expected. Think about what that actually means for a second. 4 moons, 1 planet, and at least one of them may currently have the physical ingredients for life. Not in the distant past, not theoretically, but right now, as you are reading this. That is not speculation from a fringe theory. That is the working scientific premise behind one of the most expensive and ambitious planetary missions NASA has ever built. And this is where the story stops being about old astronomy and starts becoming something closer to a slow-motion thriller playing out across billions of miles of space. In October of 2024, NASA launched Europa Clipper from Kennedy Space Center, the largest spacecraft NASA has ever built for a mission to another planet, larger than any planetary probe in the agency's history. 9 separate scientific instruments packed onto a single spacecraft, along with a gravity experiment woven into its communications. System, all built for a single, focused purpose: to determine whether Jupiter's moon Europa could currently support life beneath its surface. Not whether it once could, not whether it might have billions of years ago, whether it can right now. And to understand why that question is even being asked, you need to understand what lies beneath Europa's frozen shell. Scientists believe that hidden under that ice sits a saltwater ocean containing more than twice as much liquid water as every ocean on Earth combined. Read that again. Twice as much water as our entire planet sealed beneath a crust of ice, orbiting a gas giant 400 million miles from the sun. This is not a small discovery. This is one of the most significant revelations in the modern history of planetary science, and it has been sitting there, mathematically undeniable, since instruments aboard NASA's Galileo spacecraft first detected magnetic signatures consistent with a subsurface ocean back in the 1990s. But here is where it gets worse, or better, depending on how you look at it. Because a hidden ocean by itself does not prove habitability. An ocean needs chemistry, it needs energy. It needs the right ingredients in the right conditions, interacting in the right way. And what Europa Clipper is built to hunt for is exactly that. Whether Europa's ice shell is thin enough or active enough in certain places to let ocean material leak toward the surface, potentially even erupting in plumes of water vapor that a spacecraft could fly through and sample directly. Imagine that. A robotic probe, built by human hands, flying directly through a plume of water erupting from an alien ocean, capturing particles that may have come from an environment sealed off from sunlight for millions, maybe billions, of years. That is not paranoia. That is not overreach. That is the literal mission profile NASA scientists designed this spacecraft to execute. The journey itself tells you how seriously this mission is being taken. Europa Clipper did not simply launch and fly straight to Jupiter. It could not. The distance and fuel requirements demanded something far more calculated. a carefully choreographed sequence of gravity assists, essentially borrowing momentum from other planets to slingshot itself across the solar system. In March of 2025, the spacecraft completed a gravity assist at Mars, using the red planet's gravitational pull to bend its trajectory and pick up speed. That was not the final step. In December of 2026, Europa Clipper is scheduled to swing back past Earth itself for a second gravity assist, using our own planet's gravity to fling the spacecraft onto a high-velocity trajectory that will finally send it directly toward Jupiter. After that Earth flyby, there is no more looping back. The spacecraft commits to a straight run across roughly 1.8 billion miles of empty space, arriving at Jupiter in April of 2030. Let that timeline sink in. This mission has already been flying for years. It has already used 2 planets as gravitational stepping stones, and it still has years left before it even reaches its target. That is the scale of ambition we are dealing with here. A mission so vast that most of its journey happens in near total silence, drifting through the dark, waiting. And this is where everything changes, because Europa Clipper is not traveling alone in significance. While it makes its long journey, a separate NASA mission has been actively rewriting what we know about Jupiter's other giant moons in real time. The Juno spacecraft, originally sent to study Jupiter's atmosphere and interior, has spent its extended mission turning its instruments toward the same 4 Galilean moons Galileo first spotted centuries ago. And what Juno has found should unsettle anyone who assumed we already understood these worlds. Start with Io, the innermost of the 4, and already known as the most volcanically active body in the entire solar system. In December of 2024, Juno's infrared imaging instrument detected something that stunned even the scientists who study Io for a living, a volcanic hotspot in Io's southern hemisphere larger than Earth's Lake Superior. Not a crater, not a fissure, an eruption zone larger than one of the largest lakes on our entire planet, radiating heat so intense that it released energy equivalent to 6 times the total output of every power plant on Earth combined. 6 times, from a single hotspot, on a moon smaller than our own. Think about the forces required to generate that kind of energy output from a body that size, driven not by any star, but purely by the crushing gravitational tug-of-war between Io, Jupiter, and its neighboring moons. This is a world being physically kneaded by gravity itself, its interior superheated by tidal stress, venting that energy in eruptions so massive they dwarf anything volcanic Earth has ever produced. And scientists have confirmed they plan to keep watching that same hotspot on future flybys, specifically to see whether it changes, grows, or shifts. Because if a feature that large can appear with that kind of intensity, the question becomes obvious. What else is happening on that surface that we have not caught yet? Then there is Callisto, for decades treated almost as the forgotten moon of the 4, heavily cratered, seemingly inert, orbiting farther out than its siblings. For years, scientists using the Hubble Space Telescope had detected faint auroral signatures from Io, Europa, and Ganymede, essentially electromagnetic footprints these moons leave behind as they interact with Jupiter's colossal magnetic field, one so powerful it is roughly 20,000 times stronger than Earth's own. But Callisto's footprint remained elusive, nearly invisible, a stubborn gap in an otherwise complete picture. Then Juno's instruments succeeded in clearly detecting Callisto's auroral footprint for the very first time, completing the full auroral signature set from all 4 Galilean moons in a single observation. According to the international research team behind the discovery, this allowed scientists to precisely characterize, across ultraviolet, radio, plasma, and wave data, exactly how each of these 4 moons interacts with the magnetic storm surrounding their host planet. What sounds like a quiet technical milestone is, in reality, the closing of a scientific gap that had persisted since Hubble first started searching for it. Proof that even the moon considered the least dynamic of the 4 is locked into an active, energetic relationship with Jupiter's magnetosphere that scientists had only partially understood until now. And Ganymede, the largest moon in the entire solar system, bigger than the planet Mercury, has delivered its own quiet bombshell. Using auroral data, scientists tracking the subtle rocking motion of Ganymede's twin auroras determined that a substantial amount of salt water exists beneath its icy crust as well. This is not Europa. This is a second moon, orbiting the same planet, independently suspected of hiding a subsurface ocean. And if you are keeping count, that means we are no longer talking about a single anomaly. We are talking about a pattern, multiple icy worlds around a single gas giant, each showing signs consistent with hidden oceans, each shaped by the same violent gravitational forces, each raising the same unsettling question in different forms. What most people are not seeing is that this is not 4 unrelated discoveries about 4 unrelated moons. This is a pattern of behavior across an entire moon system, one that keeps circling back to water, energy, and the physical prerequisites for biology. And then, almost as if the story needed one more twist nobody could have scripted, Europa Clipper, a spacecraft built and launched specifically to study Europa, ended up making a discovery about something that had nothing to do with Europa at all. In late 2025, an interstellar comet designated 3I Atlas passed through the inner solar system on a one-time trajectory, meaning it would never return, never be observable again in the same way. At a critical moment, that comet moved directly behind the Sun from Earth's point of view, vanishing into a blind spot that no ground-based telescope and no Earth-orbiting space telescope could see into. It should have been an observational dead end, a rare one-time interstellar visitor slipping away during the exact window scientists most needed to study it. But Europa Clipper, still in transit toward Jupiter, happened to occupy a vantage point in deep space that no other instrument on or near Earth could match. Using its ultraviolet spectrograph, an instrument built to analyze Europa's atmosphere and surface chemistry, the spacecraft turned its sensors toward the comet from roughly 102 million miles away and captured rare compositional data during the exact stretch of time the object was invisible to everyone else in the solar system. This is not chaos. This is strategy meeting circumstance. A billion-dollar class mission, built for one target, ends up capturing irreplaceable scientific data on a completely different phenomenon, simply because it happened to be in the right place in the dark at the right time. That is the kind of moment that sounds almost too convenient to be true. And yet, it is fully documented, fully real, and quietly one of the more remarkable side stories of the entire mission. According to informed analysis from the scientific teams tracking these missions, none of this is coincidental in a broader sense either. NASA's Europa Clipper is not operating alone in this region of space. The European Space Agency's own Jupiter Icy Moons Explorer, known as JUICE, is simultaneously making its own long journey toward the Jovian system, with a specific focus on Ganymede, while also studying Callisto and Europa along the way. Two major space agencies, two separate multi-billion-dollar missions, converging on the same handful of moons within the same general window of time. That is not routine. That is a coordinated global scientific effort aimed squarely at answering one of the oldest questions humanity has ever asked, executed simultaneously by multiple space powers, unfolding right now, largely without the mainstream attention it deserves. But here is where the story escalates into something with weight beyond pure curiosity. If Europa Clipper's instruments confirm that Europa's ocean shows conditions capable of supporting life, even simple microbial life, the implications reach far beyond one moon. Scientists studying these ocean worlds have stated plainly that if Europa proves habitable, it would mean there are likely other habitable worlds within our own solar system that we have not yet identified, and hidden beneath ice on other moons we have barely begun to study. Think about what that means. It would mean the search for extraterrestrial life would no longer need to focus primarily on distant exoplanets trillions of miles away, detectable only as faint dips in starlight. It would mean the search could shift inward, toward our own cosmic backyard, toward worlds we already have the technology to reach. NASA has taken this possibility seriously enough that a separate research effort, a multi-year, multi-million-dollar collaborative project focused specifically on investigating organic carbon cycles across ocean worlds like Europa and Saturn's moon Enceladus, has already been approved to begin work, explicitly framed around the idea that these icy moons could represent not just a place life might exist, but potentially a second, independent origin of life entirely separate from our own evolutionary tree. A second Genesis, life that began completely independently from anything on Earth, following its own biochemical path, in the dark, under ice, without sunlight, for potentially billions of years. If that turns out to be true, it would not simply be an interesting scientific footnote. It would fundamentally alter how humanity understands its own place in the universe. It would mean life is not a rare, fragile accident that happened once, on one planet, under one specific set of conditions. It would mean life is something that emerges wherever the right ingredients and energy sources align, which would radically increase the statistical likelihood that life exists elsewhere across the galaxy, potentially in staggering numbers. This is why scientists working on these missions describe Europa Clipper's ultimate findings, whatever they turn out to be, as a potentially profound step forward in the search for life beyond Earth, because either outcome carries enormous weight. If Europa is found to be habitable, it reshapes the search for life in the universe entirely. And if it is found to be sterile despite having every apparent ingredient for life, that too would force scientists to rethink what conditions actually matter, since an ocean world with abundant water and energy failing to produce even the simplest life would raise its own uncomfortable questions about how rare biology truly is. And still, none of this arrives quickly. That may be the most difficult part of this entire unfolding story to sit with. Europa Clipper will not reach Jupiter until April of 2030. Once it arrives, It will not simply beam back an instant answer. It will settle into orbit around Jupiter and begin a methodical campaign of 49 separate close flybys of Europa, each one gathering another sliver of data, each one adding another piece to an enormous, slow-forming picture. Scientists will spend years analyzing ice shell thickness, surface composition, subsurface chemistry, and geologic activity before they can respond to the central question with anything resembling certainty. This is not a mission built for quick headlines. It is a mission built for a civilization patient enough to wait nearly a decade for an answer to one of its oldest questions, and disciplined enough to keep funding, building, and launching increasingly ambitious hardware toward that goal despite the wait. So where does that leave us right now, in this exact moment, as this spacecraft drifts silently through the dark toward a second gravity assist past our own planet, before committing to its final multi-year run toward Jupiter? We are living through the early middle chapters of a story whose ending has not been written yet. A story that could end with confirmation that we are not alone in our own solar system, hiding proof of a second, independent origin of life just beneath a shell of ice we can already see from Earth through a simple telescope, the same way Galileo once did centuries ago. Or it could end with silence, with an ocean full of the right chemistry and the right energy, and still, somehow, no life at all. An answer that would force science to question assumptions that have stood for generations. Juno continues to watch Io's volcanoes intensify without fully explaining why some eruptions dwarf anything else in the solar system. Callisto's newly confirmed auroral footprint raises fresh questions about how deeply even the quiet moons are entangled with Jupiter's violent magnetic environment. Ganymede's hidden saltwater ocean sits largely unexplored, waiting for JUICE to arrive and study it directly. And somewhere out past the orbit of Mars, a spacecraft the size of a large SUV continues drifting toward the largest moons in our solar system, carrying instruments built to answer a question that has haunted every civilization that has ever looked up at the night sky and wondered if anyone else was looking back. The data is already arriving. The picture is already forming. And whatever it ultimately reveals, once Europa Clipper finally reaches its target in 2030, humanity may never look at the night sky, or at Jupiter, or at those 4 small points of light Galileo first noticed 400 years ago, the same way again.